Great, thank you very much. So moving on to quadrangles on Mercury. I've been working on the Derain quadrangle, which is shown here on this first slide. It is H-10, which is highlighted there in the middle. So this represents an area that was not previously mapped by the Mariner 10 mission. So if you go to the next slide, please, I'll show you some of the new work that I've been doing this summer. So this is an animation showing the crater classification scheme. So I went through and used, Mallory published a paper recently on the degradation classes for craters on Mercury, from C1 being the oldest, and that's shown here in the blue colors, their distribution. And the youngest are the C5 craters, and those are shown in the yellowy color here, right there. Just to give you guys a sense, so we've classified craters greater than 30 kilometers in diameter for this particular quadrangle. So it's a very good exercise in patience and listening to podcasts, but it also really helped refine some of the boundaries in other units, so it's very useful. But this is sort of the biggest step from last year. If you can go to the next slide, please. Here is the whole map of the region. I'm not committing to this color scheme, I should just say that right off the bat, but here what I'm showing in the mint green, I guess it is the intercrater plains. And in pink are the smooth plains, which are two pretty well-established units. And something that I was particularly interested in looking into a little bit further and mapping this region was understanding the intercrater plains and if we could subdivide them. So similar to what Paul was discussing with the global map, you'll see here in the top right, there are some powder blue colors, I guess you can say. And so these are areas that I identified as potentially being different and could maybe be considered intermediate plains. They are quite small in areal extent, and they're sort of tenuous identifications of intermediate plains. I actually found that in my mapping, one of the biggest hindrances in continuing the mapping and dividing up the intercrater plains was actually the lighting geometry. So the lighting geometry varies substantially, and that influences how you view surface roughness, which is basically the morphologic identifier for the intercrater plane. So because of those discrepancies, it was very difficult for me to identify consistent morphologic distinctions. And so in the end, if you go to the next slide, please, I got rid of that unit because it was not very extensive, and even so in my best effort at trying to subdivide the intercrater plains, the morphologies were not exactly consistent. So here's the map as it stands. I am showing red dots, which represent all craters greater than 8 kilometers in diameter. You see the line work. I'm not showing the surface features, so some of the bright crater ejecta and sort of albedo variations are not noted here, but this is the map as it stands. And if you can please go to the next slide, which is my last slide. Here's my summary of a timeline. So the things that I have left to complete are to finalize the DOMU, and that is mostly complete. It's been pretty much done for the last year. And right now what I'm working on with co-authors, Lillian Ostrak and Caleb Bassett, is working on the COMU. So that's what we're working on now, and I hope to get that wrapped up here. Again, my schedule is challenged by COVID and by the upcoming semester and teaching requirements, but hopefully that'll be done in the next couple of months. My goal is to write the map text throughout the fall and hopefully get everything in a compliant form to be submitted by the end of this year. But again, at the latest sort of beginning of next year, prior to the beginning of the spring semester is basically my goal.